Okay, let me share my screen. Okay, you see my screen, yes?
Yep.
Okay. So, just let me close this project. So, in the previous, actually, okay. In the previous session, we actually prepare a structure together. Okay. So, and I mentioned that. So let's review again. So I just, for example, let's use that file. Okay. So, it's not closely. Okay, we just prepared this file. As I mentioned that let's grab that. Okay, this is our protein and KRAS. We're going to simulate them. Okay, you see there is so many crystal structure that we are going to the crystal border structure. So we just in the previous session we cleaned all this stuff together, and just let's move. Let's actually repeat all these together so you could actually uh, learn it more. So as I mentioned, we need to add cap, create a zero bond order or zero order bond to the metal, and create isoprene binds. So actually, we are going to prepare or starting a structure for MD. Okay, the first thing we need to just generate headsets for using EPIC on a specific pH that we are going to use, and we add hydrogen, create zero order bonds, and create disulfide. And also we need, because we are going to work with amber, we need to have cap terminal on both N terminal and C terminal of the protein. Okay, just hit process. If you have missing side chain or missing loops, you need to fill them before starting. Because this protein has no missing loops or side chain, we don't uncheck this. But if you have missing side chain, just you need to check these options too. Okay. Okay, let's start it. Okay, it's done. So this is some overlapping that during the MD is actually during the, we need to update that. Okay, this would be okay. And also, So this gonna fix by okay. So these overlapping problem are going to fix using actually after the minimization, because minimization and optimization take about 5 or 10 minutes. So we just you know, actually in the previous session you have the video, so you could just follow the step. So I prepared this structure in advance so that we could use this for the MD. Okay, so just uh, close the project. I already do the prepare the structure, so I just go to the folder. So as I mentioned before, your PDB should be clean. I mean, you see, I cleaned all this unnecessary stuff from the GDP, because I mentioned that because these proteins have a ligand named GDP and has a specific unstandard residue named the protonated serine. So we need to actually prepare or parameterize them so that the force field could recognize them as a residue, and we could run an MD simulation and simulate these residues, because this is an important part. So after minimization step, you are going to save each files, okay, in separate PDB file. Just let me show you how to do that. For example, this file. Okay, I already okay. For example, we are going to separate after minimization, after optimization, all things. We are now going to prepare the PDB file for the starting structure. So the first PDB file would be the same of protein that contain all the atom, ligand, ions, and all things you need to for the simulation. Just simply go to the file and saved file or export the structure, and you could actually find where this structure should be saved and choose PDB files, and so that hit save and prepare the name for that. So after that, we are going to separate the ligands from the protein and separate this as non-standard residue for the protein. Just simply, okay, this is the actually ligands. You could go to the files and export the structure, and its name should be your output file would be the PDB output format, and just simply type PDB. Oh, sorry. GDP, name of the file, GDP. And as I mentioned, that it should all be uppercases, because in the file, your name would be, if you see the name GDP, the name for the name of the file should be exactly the same of the name of the ligand on the PDB file, unless you get many errors. Okay, so after that, you don't need to actually create a different PDB file or separate PDB file for the water molecule, because Amber could actually take care of that. It's okay. So for the on a non-standard residue, I know that my non-standard residue is serine number 18. So just put 18 and click. So this is my actually serine. So just go to the select and invert. This command actually unselected the serine and selected all the residue except the serine. So you see, and simply delete all these. So sorry, it's not serine. Serine is number 18 because the cap terminal. Okay. Okay. So after unselected, so after that you just mention. So after preparing all these files, okay, after preparing all these files, you need to just, okay. So we have these specific files for the starting. Just we have GTP, we have the serine that I create. Just is, if you remember that we are going to that I explained that why we need to change the name of the serine to this set so that Amber could recognize between these two serine types, because one of the serine is actually the protonated. We have that one, and one of them is protonated. So if you these protonated and deprotonated serine have the same name, the Amber could treat it in the same way. So we keep adding hydrogen to the deprotonated serine, so which is wrong, because these serine should be protonated so that the structure of the protein could be saved. Okay, so or PDB or GDP is okay. You see that I actually named this GDP file exact name file of the GDP. Okay, and or this is okay, and also about or protein. I believe this is our protein. This is our protein. So we have the cap terminal. This is our first residue, and this is our serine. You see, we can, and if you want to see other serine, just you see the serine. We have we just actually change the name of the one serine that is the protonated to the CEP, so that Amber could recognize that these type of the serine is different. So now we have all things ready to start MD, and you need to just clean all these connectivity, because Amber could not actually read this connectivity from the PDB file. So all files is clean. So we could start. Okay, for the starting, this is my Bitwise client, just logging. Okay, so if you hit this, it's create you a remote desktop. This is your cluster desktop, and this is your system. This is your computer, actually. You see, this is your computer, and you could search in your computer. For example, I want to, let me see. I want to go to that folder, just simply copy and paste. So I'm in that folder, okay? And also, for working on a cluster, you need to go to the project, and this is the folder we are going to work, Def John Trent, and this is my name. And you couldn't go to the other name, other folder belongs to the other person. You see,